Right, so in this video I'm going to talk a little bit more about sets. In the first video we did the basics, the fundamentals of sets. We looked at set notation, subsets, the different types of subsets. We looked at Venn diagrams and how to represent sets using list or a rule method. Okay, so in this first thing I'm going to look at in this particular video is what's called a commutative property of union and intersection. This is union here, this is intersection. So I've done one example really. We have the set A and B. So this is the set A, this is the set B. They overlap here, and I've shaded in A union B. So I've shaded in A union B. So A union B is A or B. We had that in the first video. And over here we've got intersection, which is represented by this symbol here. And intersection is represented by this area, this shaded area here. And we say that A intersection B is this area here. And we use and A and B when we talk about intersection. Now the commutative property of union and intersection just means that if you flip these around, if you talk about A union B, that's exactly the same as talking about B union A. B union A is also this area here. If we talk about intersection, A intersection B is this area here. B intersection A is also this area here. We can flip these around. The B where the A is, the A where the B is. B intersection A is the same area. That's called the commutative property. The commutative property of union and intersection. Okay. So what I want to talk about now is what's called the universal set. The universal set. The universal set. So the universal set is the set of all elements that we're talking about, in any particular situation. So we usually use the symbol U to represent the universal set, and let's pick an example. Let's say 1, 2, 3, 4, 5, 6, and 7. Okay, so this is our universal set. So these are all the elements that we're going to talk about in this particular situation. So let's talk about a set A then and a set B. So a set A, let's say, contains the elements 1, 2, 3, 4. And let's say the set B contains the elements 3, 4, 5, and 6. Okay. So in this particular question, these are all the numbers that we're talking about, 1 up to 7 inclusive. Set A contains these elements, and set B contains these elements here. So let's represent these using a Venn diagram. Now, when we talk about the universal set here, we usually represent that using a rectangle. So we draw a large rectangle like this. We call this U. This is our universal set. Don't get this mixed up with union, by the way. This is a large U, whereas the symbol for union is like this. Universal set is a large U. Okay, so anyway, let's draw our set A and our set B. Okay, so this is A, this is B, this is our universal set, everything we're talking about. So let's fill in the numbers here. Well, first of all, we always start in the middle here, what's common to both. So what's common to both of these sets? Well, there's a 3 here and there's a 3 here. So let's put those in. That one in. There's a 4 here and there's a 4 here, so let's put that in here as well. They're common to A and B. Now in set A we also have 1 and 2, so let's put that in there. And in set B we have 5 and 6. So we've represented A and B here, but look at our universal set. We also need to include the number 7. 7 is not in A and B, so we put that out here. It's not in A and B, so now we've represented all of this information using a Venn diagram, including the universal set. Now, let's have a look at another term here that we need to use in when we talk about sets, and it's called the complement. The complement of a set. Okay, so the complement of a set is represented by a little comma like this, or a little C over the set name. So for example, if we look at set A here, we talk about A complement, or we can use AC. Some people use AC, some people use A with this little tick over it. So what does that mean? Well, it means everything not in A. Everything that we're talking about outside A. So in this particular example here, if we were to talk about a complement, what are we talking about exactly? Well, a complement here, a complement is, here's A here, remember this is all A here, including the 3 and the 4. What's a complement then? A complement is everything outside A. So we're talking about all of this area here. All of this area outside of A. Okay, this is A here. The unshaded region is A. A complement is everything outside of A. So what elements are we talking about here? Well, we're talking about 5 and 6, these two here, and also this 7 here. 5, 6, and 7 are the only elements in the universal, in the entire question that we're talking about. Remember, A is 1, 2, 3, and 4. What's not in A then? 5, 6, and 7. So that's A complement. Okay, so that's another notation, another thing that we need to know when we talk about sets. The last thing I'm going to talk about is what's called set difference. Set difference, okay? So I'll just we'll do that here. Set difference. So set difference then, okay. So if we talk about set difference, we talk about something like this. We talk about, let's say, I'll start again. Let's say we'll talk about the set A again, and let's say A is 1, 2, 3, and 4. And let's take another set called B, and we'll talk about B being 3, 5, 7. And we'll talk about the another universal set containing numbers 1, 2, 3, 4, 5, 6, and 7. Okay, so to represent that again using our Venn diagram, so again we would draw a big rectangle like this. This is our universal set. We would draw A, we would draw B. This is A, this is B. What's common to A and B? Let's say we've got a 3 here anyway, and there's a 3 here, so we put that in the middle. There's a 5, no 5, there's a 7 here, so it's only 3. So in A then we've got 1, 2, and 4 also, 1, 2, and 4. In B we have 5 and 7. And our universal set is all of these numbers here. Anything missing? Let's see, 1, 2, 3, 4, 5, 7. So 6 is missing. So we have 6 here in the universal set. It's not in A and B, so we put it out here. Now we're talking about set difference. What does that mean? Well, let's have a look at what's called A less B. A not B, or A less B. This is what's called set difference. So what does that mean? Well, it means everything in A but not B. Everything in A but not including B. So what does that mean? A less B. So we want everything in A. This is A here. This is our set A here, 1, 2, 3, and 4. But we must exclude B. So this 3 here is in B, so we must exclude that. So A less B, or A not B, would be this area here. A less B. So our A less B would contain the elements 1, 2, and 4. Okay. Now what about B less A? We'll do it the other way around and see what happens. We get so we want B less A. So this is everything in B but not A, or less A, minus A if you like. So what are we talking about there? Let's have a look at our diagram. So we want everything in B. Here's B here. This is all of B. But we don't want A. We want to exclude A. This 3 here is part of A, so we want to get rid of that. So we're just talking about this area here. So that would be this area here. That's B, everything in B, but take out A. Get rid of this bit here, that's part of A. So what are we talking about there? So we're talking about the elements just 5 and 7. Okay, so that's what's called set difference. Okay, so finally what I'm going to do is just do a quick problem, a quick kind of a practical problem. This is it here. So we're going to have a look at 8 students have been to Germany, 6 students have been to France, 5 students have been to Germany and France, 4 students have not visited either country. So we want to represent this information. That's the first part here. Represent this information using a Venn diagram. So you always draw your universal set anyway. So we're going to draw a big rectangle here. And this is our universal set here. And we're talking about two things here. We're talking about Germany and France. Germany and France. So we need 2 circles. Later on we'll do questions involving 3 circles, but for the moment we're just looking at two circles. So we're talking about Germany and we're talking about France. This circle here represents students who visited Germany. This circle here represents students who visited France. And the universal set represents all the students that we've spoken to. So we've sampled a certain number of students. We've gone out and spoken to a certain number of students. We'll look at how many we've sampled in a minute. So let's read the question again. 8 students have been to Germany. So 8 students have been to Germany. So we need to put 8 students in here. Now this section here, this German section here, is split into 2 sections. This section here and this section here. This section here represents students who've been to Germany only. This section here represents students who've been to Germany, but they've also been to France. They've been to both countries. This section here represents people who've only been to France. And the section out here represents students who have been to neither country. So we have 8 students who've been to Germany. So 8 students would need to go in here. But we don't know how to divide those up. We don't know how many have been to Germany only and how many have been to Germany and France. So I don't know where to put the 8 or 7 or 6 or 5 in here. So let's just put the 8 here to represent 8 students who have gone to Germany. 6 students have been to France. Again, same logic here. I don't know how to split up that 6. Are all 6 here or all 6 here, or do we need to split it up in a particular way? Well, we'll just put the 6 here just to tell us that 6 students have gone to France. Now let's read on. 5 students have been to Germany and France. 5 students have been to Germany and France. So 5 go in, the number 5 goes in here. So 5 students have been to both. 4 students have not visited either country. So 4 goes out here. These students have not visited either country. Now let's go back and read the entire question again. 8 students have been to Germany. 8 students have been to Germany. So this entire circle represents 8 students. But now we know that 5 students is in this section, so there must be 3 students who have visited Germany only. Now 6 students have been to France. 6 students have been to France, so we know that 6 students is going to be represented by this circle here. We know that this section of this circle has 5 in it, so there must be 1 out here. 5 plus 1 gives us 6. Now we've filled out every section of the Venn diagram. There's this section, 2, 3. There are only 4 sections that we need to fill out. So let's answer the questions then. We've done question 1 or part 1 here. We've represented the information using a Venn diagram. How many students have visited Germany but not France? How many students have visited Germany? These are the number of students who have visited Germany but not France. These students here have visited France. So our answer to part 1 is 3. So 3 students have visited Germany but not France. Okay, so that's this part here. Okay, how many students are in the group sample? So how many students did we talk to in total? Well, we spoke to 3 plus 5, which is 8, plus 1, which is 9, plus 4, which is 13. So our universal set contains, we spoke to 13 students in total. So the answer to part 3 here is, if you like, 13. Universal set contains a total number of students, 13 in total. And that's it. That's all I want to do in this particular video.